Now, as some of you asked me to make an animation type of video to show the interconversion of this Shawhorse and Fisher to Newman and all this, right? I have made this video. I am trying to make such a thing. So let's see if it helps you. See, in this one, in this screen, you can see on the left hand side, I have drawn the Newman projection, right? This is the model for Newman projection of staggered ethane, whereas on the right hand side, it is the eclipsed ethane, right? Now, see, if I just rotate it a bit, then I get the Shawhorse of staggered ethane. Now, this is the Shawhorse of staggered ethane shown on the left. See, I can, for seeing the Newman projection, I have to view through the CC bond, right, in the direction of the CC bond. Now, as you view it like this, this is our Shawhorse in staggered. Similarly, if you come to the right hand side, this is the eclipsed form of in Newman. Okay, now you see, this is the Shawhorse. See the dihedral angles here. You can see the dihedral angle between this H, carbon and this H is 60 degree, right? Whereas in this case, see, is 0. The CH bonds are eclipsed, right? If you view it from like this, you can see only 1 carbon and 3 hydrogens, though it has 2 carbon and 6 hydrogens. Okay, so this is our Newman projection to Shawhorse. Okay, and for viewing the Fisher projection, we should consider the eclipsed form, right? Now, eclipsed form, you have to take it. This is again the eclipsed form, same thing, right? So that, and you now view from the top, right? You have to view from this side. So how it will look like? It will look like this one. This is our Fisher projection, right? So we'll explain it a bit more with another example, because these all are hydrogens, so it's a bit difficult. See, here in this example, we have different bonds attached just to show different various colors, so that it's not confused with hydrogens, right? So this is again a eclipsed form of any species, right, with the dihedral angles 0, right? Okay, now for viewing the Fisher form, we have to view it from this side, or you can view it from any of this side, right? But let us see if what it looks like if you view it from this side. Okay, so that means we will be forming something like this. Now you see, if you draw it here in the two-dimensional plane, what does Fisher projection say? That the horizontal lines will represent the bonds which are towards you. That means here you see the oxygen and nitrogen are towards you now, right? Whereas in this carbon atom, the chlorine and oxygen are towards you, right? So we have to draw it like this. And similarly, the fluorine and the nitrogen, another nitrogen attached, are behind the plane, so they are on the vertical line. Okay, now suppose if you see it from this side, right? Suppose you view it like this, right? Suppose you view it like this, then you will draw another form of Fisher projection. So this time you have drawn it, you have to draw it like this. Okay, right? So are these two different? No, they are not different compounds, right? In the next lecture, we will see, we will assign the RS configuration, the absolute configuration to each carbon atom, and we will see that in both cases they are same, right? So they are not different, they are identical compounds. One more thing, someone of you asked that to show me the interconversion between this tetrahedral form and Fisher projection of a single chiral atom. Right? So we have taken a chiral carbon type of thing. So a carbon attached to 4 different groups. Right? This is arbitrary. Just follow the colors. So for Fisher projection, right? So you can draw like this. So this is our Fisher projection, right? So the atoms on the vertical line, right, is pointing towards you. See, they are pointing towards you, and the blue and the yellow are away from you on the vertical line. Right? So in the tetrahedral form, how can you draw this? You can draw it like this. If you just pull the red atom towards you, right, so that such that the now this bond, the blue atom and the this yellow atom and the carbon are on the same plane, and the this white atom is behind the plane. Okay, you can also draw it like this. These two again are same and identical compounds, they are not different. Okay, so I hope that it will be of some help to you. So thank you.